Ensoftec has developed a series of videos for the selection and design of stormwater facilities for land disturbance projects. In this video, I shall show you the design of dry swales using SWMSOFTVA. Virginia Department of Conservation and Recreation, or DCR specification number 10 gives a complete description of these facilities, their performance and criteria for design, their feasibility and design applications, regional and special case design adaptations, their construction and maintenance. The pictures and tables shown here are from these specifications. Dry swales are essentially bioretention cells that are shallower, configured as linear channels, and covered with turf or other surface material. They, like grass channels, are a preferred stormwater practice for linear highway sites. Table 10.1 gives the runoff and pollutant load reductions for different levels of design of dry swales. The maximum contributing drainage area to a dry swale should be 5 acres, but preferably less. The bottom of the dry swale should be at least 2 feet above the seasonally high groundwater table. Table 10.2 gives the dry swale design criteria. Underdrains are provided in dry swales to ensure that they drain properly after storms. The minimum diameter of an underdrain should be 6 inches. It should be encased in a 12-inch deep gravel bed. Pre-treatment for a dry conveyance swale is in the form of a minimum 10 feet wide grass filter strip. This grass cell is located at the upper end of the dry swale segment, with a 2:1 length-to-width ratio, and a storage volume equivalent to at least 15% of the total treatment volume. The swale should also convey the locally required design storms, usually the 2- and 10-year storms, at non-erosive velocities with at least 3 inches of freeboard. SWMSOFTVA deals with the design aspects of dry swales. Let me open a project and go to the BMP design. I am going to use the example project that we created earlier. BMP2 is a dry swale. I go to File, Design BMP Facility. This opens the dry swale design screen. You will notice that the required treatment volume is already populated. I enter the soil media depth level. This is 18 inches to 3 feet for Level 1 design, and 2 to 3 feet for Level 2 design. Next, I enter the surface bonding depth. The surface bonding depth, which also is the maximum height of check dams, should not exceed 1 foot. This gives the effective storage depth, and the required storage area based on the accepted void ratio of 0.25 for soil media, and 0.1 for gravel. The dry swale section details are entered next. The bottom width of the swale varies from 4 to 8 feet, to ensure that an adequate surface area exists along the bottom of the swale for filtering. Channel side slopes should not be less than 3 horizontal to 1 vertical. The recommended longitudinal slope for the swale should generally be less than or equal to 2% for a Level 1 design, and less than or equal to 1% for a Level 2 design. Slopes up to 4% are acceptable if check dams are used. The height of the check dam relative to the normal channel elevation should not exceed 12 inches. After I key in height of channel and the required freeboard, which is 6 inches, I click on Design Swale button to the right. All calculations for dry swale design and performance are done. The Manning's N value is automatically adjusted between 0.03 and 0.2 depending the depth of flow in the swale. The check dam spacing required to achieve the effective swale slope is calculated. The remarks will tell you if the water quality design is satisfactory or not. Swale section geometry can be adjusted to achieve this. The program also calculates the adequacy of the swale to convey the 1-year, 2-year, and 10-year design discharges satisfactorily. I go to the top menu bar and click on File, Save. This will save all the data including results of analysis. To print the results, I go to the top menu bar and click on File, Print. The print report, which is in Excel format, gives a complete output of dry swale analysis. This completes the design of dry swales.